Welcome back, everyone. Number one, quick announcement. Next Monday, we will not have a lecture. So our next lecture in a week, Wednesday, Monday, you are free. Previously, we was talking about the model view controller. Model view controller, very simple concept. Put our classes in different boxes, packages if you want, but different folders. Separate what is going to be the graphical user interface, widgets, frames, panels, from the functionality of the system, and the most important, from the controllers. You know what? Common errors in people that learn how to do programming. Common errors when we are new developing software. Put everything in one place. Two common errors. Number one, obviously, with the model and the view. Having in the same class graphical user elements, drawing something, and then in the same class, adding functionality, data structures, handling data, processing data, whatever. That is a very bad idea. Recommendation number one, whenever you do a system, your system, separate the graphical user interface from the functionality and separate literally different classes, never in the same class, showing something, processing the output, and also doing the functionality. Obviously, we're talking about software that is a big software system. If you remember, we're not talking here about building the house for the dog. We're talking here about building any of the things around the campus, big things, in terms of software, obviously. Do not put together model and view. Common error in your assignments, common errors with the software. You want to be able to have the same functionality in a cellular phone, in the desktop, or maybe a web application. The functionality is the same. You should be able to reuse 100% the model. And the only thing that you could do, need to do, is to change the different views. The software, the same. Now, that is easy to explain. However, this one, the controller. Help me, which are the controllers? If we're talking about a desktop application in Java, what are the controllers there? Java application desktop. Do we review that the view is the graphical user interface, the model is the functionality, the controllers, the listeners, correct? Your listeners, they are this interface between the graphical user interface, the events in the widgets, and triggering actions in the functionality, triggering actions in the model. The user is working here with the view, and the flow for your software should be the view is in communication with the controllers, the listeners. The listeners are the ones that decide which action is being triggered, and is going to trigger that action in the model, or is going to ask the model to work and do something, whatever. And the models, they are going to create results. And those results usually are going to imply to put something on the screen. That loop could be the ideal communication between these elements. Obviously, sometimes we're going to need feedback, so the communication here is going to be bidirectional, and the same thing could happen with this one. Those two, it could be some kind of feedback between the communication of the models. Now, if these are the listeners, the common error when we are working with big software is to create a class, like for your projects, main, and do that class to do these two things. The logic, the business logic is the model. All the logic, all the functionality is the model. The controllers are just the listeners. Think about this. The controller is just the connection between what happened in the view and the functionality that is going to be triggered. It's just this middle guy to connecting this with this. And I am going to show you an example with code. This thing is something that we do. It's something that you are told to do when you take your programming 101 class. You can have a class. That class is going to have graphical elements. You can extend from JFrame. Okay, you want to use listeners, for instance, the action listener. The same class implement action listener. That is a common example in the books. It's a good example for teaching programming. It's a good example for learning. The goal here, when we're talking about the architecture of a big system, is, you know what? One class should do this. Another class, a different one, should do this. Because if one class is doing the extend and the same class is doing the implement, what you have is one class that is at the same time a controller and the view. Again, in a small system, it is fine. In a small system, you can have in one place, in one file, all of this together. What we're talking here is big systems. Separate the view, separate the controller. Now, if I ask you to separate, the question is how? Can that be done? Yeah, we can do it. This is an example of the source code for one view. Again, your class main, extending frame. This is a view. It's a view, and this one is going to have these widgets, a layout. We're going to add the widgets, the common things that we do in a graphical user interface. A constructor and the main method. This is very similar to your projects, what we commonly do. Now, do you remember what we put inside of these parentheses usually? When you do this widget dot add action listener, the widget can be whatever, add action listener, parentheses, what do you usually put inside of the parentheses? And why? That is correct. You usually put this. Do we know why we put this as a parameter there? The parameter there is the object that has the method action perform, right? And usually what you do is this class is implementing the listener. This class is the one that have the method action perform. And you just put here this to tell the computer that here in this class is the method that is the control for the listener, the method that is controlling what action is going to be triggered. The only thing that the pattern recommends to you to do is, well, forget about that. It's not going to be this object. It's going to be a new one. Another one. So in this scenario, and let me be clear, I am using as a name for the class controller. That is not mandatory. I am using the name controller just to follow the template. So for you to follow me with the example, but the name controller is not mandatory to be used. So I have a new object, controller, new controller. I need to create a class controller. And I am going to use that guy here instead of this. If I am doing the graphical user interface, I am going to be worried for adding the panels, the widgets, the frame, the main, etc. And the only thing that I am going to do is to add to all my widgets as a listener, as a controller, this object from a class that I don't care who created the class. This is my work, and I am going to use this class in the same way that I am using other classes from a library. Someone else, another programmer, can create this class, another file, the class controller. And this class is the one that is going to be a listener. We are separating the graphical user interface and all the things that a graphic designer need to do regarding the layout, where is going to be this element and the other, right, left, maybe the colors, whatever. All those things are going to be here. The actions that are going to be triggered in another class, the controller. Obviously, the example is with one class. We can have more. I am using here use one object controller, and I am passing the same one to all my widgets. You can have controller 1, controller 2, controller 3, 3 different objects, all of them from 3 different classes, maybe all that classes in the package, in the box, controller. All the classes that control the execution are here inside. The example is only one. This class, the only thing that I have in the class, the only public thing is my method action perform. Do you remember that the listeners are basically observers? And if you remember, the observer pattern is this method is going to be called every time that something happened with these widgets. I don't care where those widgets are. I don't care if they are in the left, in the right. It's not my problem. But the method is going to be called when any of these receive an event. And in particular, because they are bottoms, every time that they are clicked. When I click this one, the 3, the 2, the 1, this method here is going to be called. For the developer working here, what I am going to do when they call this method, the first thing that I need to do is to identify who is the widget, which widget was clicked, what is the event, the observable that received the event. And as you can remember with the observer pattern, the good news is that the method is called and you have a parameter, and the parameter have the information about what do you need to know. Notice these guys. Error number 1, a novice developer. A novice developer is going to put these variables global. Error number 1, and you can find that error in several programming books. The widgets as a global variables. Wrong. Error number 2, the same class have the widgets and the events. Wrong. Local, 2 classes. And you are working with the same instance, the same 3 labels, bottoms, or whatever, the same widgets. Now, when you click on them, you have this information and this object, among other things, have getters methods. Getters to collect access information about the event. One of the things that you can collect is the action command. The action command is a string, And in particular, I am sure that you can identify what is that string. If we go back, the string that you have inside of the widget, right? Like if you have this okay and cancel, that okay and cancel, those words are the ones that you can get here. So you can know exactly which was the option on the screen that the user select. And the only thing that the controller do is here, here, here to trigger an action. In this example, the only thing that I am doing is to printing a message, just to give you the example, and you can run this if you want. But you can imagine that in order to complete this program, this is the point in which you call a functionality in your model, in a class in your model. What do you need to do in order to call that functionality? Two options. Option number one, a local variable here and call the method. Option number two, an attribute in the class and call the method here, which basically is going to represent that this class, the controller, is going to have an association relationship with the model, or it's going to have an aggregation or composition to the model, depending on whether or not the variable is global. But it's going to be aligned because this one, the controller, this class, is calling a method in one of the classes that you have in your model. I am representing here the classes, but also we can represent that inside of folders. We have the class diagrams, but we have also package diagrams, the package folders, and the same relationships that you have between the classes. Well, somehow you can represent them with packages, these folders connected, just because one class inside of one folder is using another class inside of the other folder. Model view controller. Again, two things that I need you to do. Do not put functionality in the classes that are creating the view, and please separate the controllers, the listeners, from the view. That is the correct way to do it. That is what this is asking you to do. Again, makes sense in big systems. Probably for the house of the dog, for these small pieces of software, hello world, these do not make sense. Usually the main is a very good point. Usually your main can be two things. In our examples, something that I do is I put the main as part of the view. Something that we have been doing is make the main extends JFrame. So in that scenario, when we use inheritance from JFrame in main, and main is the class that have the public static void main method, main become part of your view. Now, another option that is also common, not the one that I have been using, but a possibility. Another option is to have the main here as part of the model, which means that the main should not inherit from JFrame. It's not going to be part of the view. It's going to be used a class that is going to be part of the functionality. But then if I put the main here and the main is not inheriting from JFrame, then this main is going to create an object. And that object is going to be an object from a class that is the frame. And there is going to be a connection between this main and this object. Again, it could be association or it could be composition aggregation, whatever. But this is the scenario in which you have the main. The main is not a frame. And what the main do is to create an object, local or global, from another class. And that other class is the one that is the frame or the graphical container. So your main can be in the model or can be in the view, never in the controller. That do not apply. Good? Easy. Next. The other pattern that we talk about is Blackboard. Blackboard. A very simple idea. Think about a classroom. In a classroom, you have students. Instead of students, the pattern called them sources of knowledge. So in a classroom, you are a source of knowledge. And there is another entity, control, and you can imagine, well, your instructor. So you can imagine in a classroom, a lot of students, several students, and one control, one instructor. And all of them share, literally, this space, the Blackboard. Well, the whiteboard, if you want. The whiteboard, the Blackboard, the name of the pattern, and you read the paper and you can make a connection between the paper, the 90s, and the color of the Blackboard, whiteboard. So for the pattern is Blackboard, thinking about previous things. That space is a space in which both the students and the professor can put information. It's a shared space for adding information or collecting information. The idea of the analogy is it doesn't matter which of the students put something in the whiteboard. That information is public for all the other students and also for the professor. And all of them can put things in different places. It's a shared space. All of them have access. Now, obviously, and you can imagine, this guy, the control, the instructor, can go and delete things or change things, having the control of the space, right? The idea is just like in a classroom. If we have several markers, all the students can be using the whiteboard at the same time. There is no only one. There is no one sequence. That order do not exist, at least not in the pattern. And if you think about the classroom, could be the same idea. If we have enough number of markers, if each student have a marker, all of you can go to the whiteboard and put something in a random way. Unless the controller, the instructor, tell you something different. And in this case, the idea is that the controller is controlling the resource, not the students. And this is a big point to notice. Everything here is all about the resource. All the arrows that you saw in the picture are from the controller or from the students, the knowledge of the source of knowledge, to the whiteboard. Never, never, never the controller interact with the knowledge of source, or one knowledge of source interact with another knowledge of source. Think about a scenario in a classroom in which the instructor never talk with the students and the students cannot talk between them. The communication never happen between the entities. The communication is using the space, using the whiteboard. This is a big difference with other algorithms, including, producer, consumer, philosophers, things like that. We are not talking about synchronization between entities. This is there is this space. We all can use the space, and there is one entity that have full control of the space, and there are others that have access, but there is someone could delete what you did before. the controller. Makes sense in theory. Now, this is the model that we know as the Blackboard pattern. This is the description that you read. And again, the most important thing for you to remember for your exam, for your quizzes, for your software, the only arrows here, the only communication is between the Blackboard, the shared source of information, and the entities, never between these two or this or the others. That is the signature of the pattern. Now, the picture is very simple. Again, an architectural diagram. Use boxes with lines, and we add arrowheads. Nothing new. The programming. What do you think about this? Use an idea, abstraction, going down to a class diagram. Could you agree in a solution for the Blackboard that is going to include the following elements? And I am going to follow with this analogy about student and professor. Just, I think it's easy to remember. Can you agree with me that in order to create a piece of software that represents this scenario, I need this, I need this, and I need this. I need three things. Therefore, I need three classes. Yeah, from one of the classes, I am going to create several objects, but basically I need three classes. 1, 2, 3 classes. Good. Now, 3 classes. 2 of those 3 classes, according with my description, they are going to be working at the same time. The description that I shared with you is this idea of, well, several students can be doing something with the whiteboard at the same time. And the professor is also maybe doing something. So we have this idea of concurrent events. It's not just like there is a line and one student can use the whiteboard, and when that student finishes, the next and the next and the next. That is not the concept here. Is several entities around, all of them can be working. We are talking about concurrency, multithreading. And my question for you is, what do we do in programming in order to implement multithreading? And hopefully you remember, you're aware, you have 2 options, the official options. You have a class thread and you have an interface runnable. 2 scenarios, right? The one that I am going to show here is, well, let's use runnable, and that is the reason because that box appears there in my diagram. Yeah, implement runnable or extend threads, your 2 options, right? So I use randomly, not particular reason for my diagram here, a diagram from a previous class. I decided to use runnable. Again, no particular reason, 2 options. I choose the second one, runnable. And when I use runnable, something that you know is runnable is an interface. And in order to connect the interface with my classes, in this case, student and professor, those are the 2 things that are going to be concurrent. What I am going to use is a connection realization, inheritance with this dash line, right? So this and this become part of my diagram. Can you notice that we are moving from this scenario with use boxes and lines, very, very abstract, to something that is more like software engineering product, UML, something more technical, but the ideas are the same. And probably for everyone, with or without background in engineering, this could be kind of, makes sense. There are a group of things interacting with something at the center. But this is more technical, and the reason for this is telling you which source code you need to create. Because this one, the runnable, the connection, the classes, It's telling you how many files I am expecting in your project. Moreover, some source code, implement Runnable is going to be there in 2 files, and so on. Well, okay, implement Runnable. Moreover, next, I am thinking about student and professor. They are going to be threads. They are going to be using the Blackboard. Using the Blackboard, hopefully you agree, is using the arrow. Blackboard, what we call Blackboard in the pattern here, is up to us to put there a data structure for the Blackboard. Looks great to think about, oh, there is a Blackboard, a place in which the threads are going to be writing. In the software, that is not exactly what we want. Maybe you want a 2D array, a real 2D array to represent the pixels in the whiteboard. Maybe for your problem is use a linked list or a hash map, or you need to select the data structure for the Blackboard. That is the technical part. Question: what are we going to do to provide access to the student and to the professor to the Blackboard? Because I am adding these arrows, which means that I am calling methods in the Blackboard from student and from professor. But in order to have access to those methods, I need a reference. I need an object, right? What are you going to do to provide access to the Blackboard, a student and professor? And you have 2 options. Can you figure out the 2 options? Just imagine that I asked you to do this program. Okay, let's do this. Number 1, inheritance. You can do it, but think about the semantic. If I use inheritance and I put Blackboard inherit from a student or a student inherit from Blackboard, semantically it's kind of weird. I mean, the student is a child of the Blackboard, or the Blackboard is a child of the student. Doesn't matter which direction you use, it just sounds weird, right? So even though it works, I agree with it could work, it's not a good idea just because it didn't sound good. Again, the student is a child of the Blackboard, or the Blackboard is a child of the student. It's just not what you want. Remember, somehow object-oriented is about representing with classes the same thing that happened in the real world, because it's the best way to understand things. So that inheritance probably could not be the best thing. So let's avoid that solution just because of that. So the other one, aggregation. Aggregation. What you are telling me is passing as a parameter the Blackboard to a student and or to professor. Could you agree with that? Aggregation basically is, in this case, passing the parameter, and passing the parameter is something that we review as dependency injection. If we do that, I am going to follow the example with dependency injection. Who is going to do the injection of the dependency? Where that is going to happen? Could you agree that what is going to happen is this class main, or I am going to call it classroom, just to follow the scenario? Can you agree that here I could have my main method, lowercase, and there I can create student, several students. Here, I can also create classroom. And just because I create classroom, I can pass as a parameter the classroom object to the student objects. Moreover, I am going to create also the professor, only one, and therefore I can pass as a parameter also the Blackboard object to the professor objects. So if you are thinking about dependency injection, if you are thinking about aggregation, the only way that you can do that is if one class, in this case main, is the one that create the three of those. And having creating all of them, the Blackboard, the professor, and the students, that one can pass as a parameter to the student and the professor a reference to the Blackboard. So they are going to have access to that. Makes sense? That was solution number one. Solution number two. This is a good solution. Check. That is what we could do. Just to complete my answer, there is a second solution. There is a second solution in which I could do only two connections, in which I am not going to create a Blackboard in classroom. Moreover, I am not going to do dependency injection. I am not going to pass as a parameter the Blackboard to the student. I am not going to pass as a parameter the Blackboard to the professor. And therefore, my diagram is going to look like this. What should I do? Yes. My diagram is going to look like this, and probably either you are going to put a private constructor and an entity here, or you're going to have this reflexive connection. But basically, that represents the singleton that you are talking about. Can you imagine the solution in which the Blackboard is a singleton? Can we agree that if we make Blackboard a singleton, both student and professor can just do something like Blackboard dot get instance dot and have access to the functionality? If we think about the scenario that I described before, my classroom. In the classroom, there is one Blackboard, only one. Well, in the classroom that I represent here, right? In the university, probably we have three in some places. But for this scenario, it's only one Blackboard. And only one Blackboard in terms of software, the singleton pattern. And if we follow the singleton pattern, then there is no connection here. Two solutions, the final result, the same. In one, you are passing a reference as a parameter, you use the parameter, you have access to the Blackboard. In the other, you do not need the dependency injection, you do not need to pass the parameter, you are using a pattern, the singleton, you have access to the Blackboard. Two solutions, at the end, you achieve similar results. Up to you. Depending on whether or not it is important for you to specify that the Blackboard is one and only one. Sometimes it's important. If that is important, use the pattern. If you use the pattern, this is the diagram. If you do not use the pattern, the diagram is the one that I showed you before. Makes sense? Oh, one Blackboard per, if you use the singleton, it's one Blackboard for the full system, right? Good. Can I ask you in the next assignment to implement model view controller and Blackboard? Are you following me with the implementation, with the source code? And hopefully the answer is yes, of course. Source code here. All your options, the same thing that we discussed before, used for you to remember and review for the exam. Source code in an example, and hopefully you can help me with the class diagram and check if the ideas that we shared before match with this source code example. Let's see. I have my classroom here, the one that I showed you before. And this classroom is the one that have the main. Moreover, inside of the main, I am creating 3 threads. 3 threads, and I am passing as a parameter one object student, another object student, an object professor, and I put the 3 threads to run. Is the source code clear? You read this and you know exactly what is happening there. Yes or no? I have 1 yes in the chat. Hopefully that represents every people connected. Okay, good. Question for your exam. Can you help me with the class diagram of this source code? I give you this source code, this picture, and the question is class diagram. I am going to use only the classes as a boxes. I am not going to go into the details of the variables and the methods. It's something that you can do, but just to be sure about the connections. I have a classroom. It looks like I have a class thread. It looks like I have these students, professors, and so on. I'm going to put student. Tell me, what is the connection between classroom and thread? There is any connection between these two for the class diagram? Connection, yes or no? If yes, which is the type of the connection? Hopefully you can agree with the association. For instance, the object calling a method. That is association, right? And it's local, so no diagonals, no composition or aggregation, association. Agree with that one. Any connection between classroom and student? These two. Yep. You make the point, dependency injection. We are using a student for dependency injection. We are not calling any method from a student, right? So I am creating the variable, but I am not using the variable. It's used, I create the variable and I send the variable as a parameter. Remember the factory pattern? Dependence. Did you notice what the class diagram is telling me? The class diagram is telling me that for classroom, thread is important, more important than the student. Just because a student is just a parameter, but thread is the one that is doing the work. Start. Whatever is happening inside between thread and student is something that we do not know. We talked about this in a previous lecture. I am sending as a parameter student to thread. Something is going to happen. Thread is going to do something with the student, but I do not know. And the level of abstraction in my diagram is just this. I do not need to show or figure out or create any connection between these two just because it's not explicit in the source code that I am showing. Period. Probably if I review other, it's going to be different, but not so far. Okay, give me a second. Let's continue. So this is the diagram for this class, and it's just the beginning. Good, done. It's going to start 1 professor and 3 students. We do not know what is going to happen, but done. In this example, I am going to follow the idea with the singleton, and you can notice I am not creating here the Blackboard. Now, the classes, the professor. According with the description that we did before, it's going to be runnable. Okay, implements is an interface. When you have a class and that class implements the runnable, what you are doing is to commit to create that class, that method, to override the method. So you have your method run. And inside the run, usually what is going to happen is you are going to have this loop. You want the professor or the student or whatever to do something forever, as long as the program is running. For my example, I am going to be printing things. As professor, what I am going to do is to print what others put in the Blackboard. And I am going to have access to the Blackboard in this way. Did you notice the singleton? I haven't shown you the class Blackboard, but you can imagine uppercase B, that is a class, get instance, and selecting a particular action. The action is read. I am going to read. It's a getter method. The getter is going to give me a value. What I am going to do with the value here is whatever I want. In my example, it's just getting the value and printing on the screen. Yeah, that is correct. That get instance, the static method public that is going to return the instance. Yeah. So that is the reason, because I do not have a connection between main and Blackboard. It's going to be created automatically by the first thread that tries to use it. So other than that, as a professor, I am going to sleep for 1 second. Literally, it's like I am going to read the whiteboard, the Blackboard, print something, sleep. So while I am sleeping, my expectation is that the students are going to be writing new things. Done. You can imagine that for a student, the same is going to happen. Student is also runnable. You can have variables and additional methods, constructors, whatever, according with your problem. But the only commitment that you do is to have this override and to have this run, just like before. Something for a student. You can imagine that my representation of Blackboard is going to be somehow connected with an array, somehow connected with a linked list. And something that I can do is, well, organize a little bit my students, and you can imagine the Blackboard divided in several different spaces. And used by default, you can assign each student which one space in the Blackboard. That is useful. So you know that something is here. This thing is for student 0, something is here, student 1, student 3, student 4, and so on, instead of having just random information around the whiteboard. So that is the reason, because I have an ID for the student. As you noticed before, when I create the object, I pass this 0 and 1. It can be more. And that is the reason, because I have this constructor to provide a value to that ID. And that is the reason, because here, using the singleton again, now to write, I am using that ID as the index of the place in which, as a student, I want to put something. And as you can notice, the students are just going to write random numbers in the whiteboard, child space. So the students write something, go to sleep. The professor reads something, go to sleep. And because I know from the beginning that I have 2 students, as a professor, I read the space 0, the space 1, my student 0, my student 1. This ID is going to be 0 or 1. That's it. Source code, separation of concerns. The classroom, create everything. The professor is reading. The students are writing. And you can put more complex actions. But those 3 things, done. The last thing that we need, the Blackboard class. We have been using Blackboard. I am sure that you can imagine the class. Number 1, the class do not have any inheritance, any interface. It's just a trivial class. It's going to be a singleton. it's going to be a singleton, and because it's a singleton, you can imagine, number one, that line 5 is because of the pattern. That line 5 is not something in the functionality. That line 5 is something because the pattern tells me that I need an instance that is static from the same class. The next line, the 6, that one is part of the functionality. I need this vector. In fact, this is going to be really the Blackboard. That is going to be the child memory space. That is the place in which the students are going to be inserting information, that vector of numbers. Other than that, we are back here with the pattern. The constructor should be private. The constructor do the new for the data structure. The constructor is going to include zeros, 2 zeros, just because I have 2 students. The recommendation here should be to pass to the Blackboard the number of students, do this as a parameter, but well, just for the example, I know that I have 2, I am initializing 2. The getter, also from the pattern, you should be familiar with this if condition, the null, and the return. Done. And these are the 2 methods that before we use. The method for reading and the method for writing. Adding or returning the data. Done. Nothing fancy here, nothing new there. It's just the common add and get of the data structure that we create. And with that, we are done with a common trivial implementation of the Blackboard pattern. Makes sense? I show you a trivial example. I am going to ask you to do a little bit more things more complex for your project. But if you follow this template, these ideas, hopefully you have clear that anything that I ask you to do that is more complex than this is just adding more code inside of the methods. But the structure, the number of methods and the connections is just the same that I am showing you here. Now, question for your exam. Class diagram for one of these classes. If I have my class student and I ask you, according with what we have here, to create a class diagram, what classes, what connections are we going to have between student and Runnable, and looks like also Blackboard is going to be involved. The connection between a student and Runnable, we already showed that before, so hopefully there is no problem. Remember that it's that one. My question could be more about, there is a connection between a student and Blackboard? And if so, what is the connection? And I am glad that you mentioned math. Yes, math is also connected. Advice, remember, your class diagrams are models. Models have levels of abstraction. Something that you want to do is to show the correct level of details. My advice, usually we do not need to show the class math in our class diagrams. If you delete this from here, that could be better. That space clean instead of one more relationship with the math and it's like too obvious. But again, use a recommendation, but if we go with the specific, the details, yes, math have exactly the same rights to be there like Blackboard, because they too are connected, they too are associations. Good. Okay, that was the Blackboard. Now, next one, client server. Client server is very simple. We have clients. We're talking from the point of view of the software. And we have servers. The difference between a client and a server in terms of software is they are running in different computers. The only thing that the pattern is showing you is two softwares running in two different hardware devices. Two computers, one cellular phone and one computer, one laptop and one supercomputer. That usually is the one that we call the server. Two different places. That is the concept. One place is the client, another is going to be the server. The client, the one that needs the other, the server, the one that is helping the other. Two places, and one is the most important. And usually they are connected, and they are connected in a physical way, and that physical way is a network. And today, well, it is common to have this. The internet, it uses a network. It's not mandatory that this is working with the internet, right? So a network, a local area network, whatever is used, there is a connection that implies communication. And obviously there are something that we represent with a box that is providing that physical connection, wireless, a cable, and all the infrastructure that we don't care about it, the routers and so on. So client, server, and the network. When we use this, I give you the full information, but you know when. Client and a server, if you need to do something in one device, and that device do not have enough power to fulfill that responsibility, you use a big computer. And that big computer can just share the result with your small device. Think about voice recognition. When you're working with your cellular phone and you're trying to do voice recognition, really the voice recognition thing do not happen in your cellular. It's too small. That happens in some other place. Your voice go and come back with some kind of result. What do you do to program an application like that? What do you do, for instance, in Java, if you have something and then you want to connect that something, a software, a class, and you want to connect that class with another class in a different computer? We're talking about Java. In Java, I have a piece of software in my computer. That piece of software, object-oriented, is going to be at least one class. In your computers, you have another piece of software. That piece of software is going to start with at least one class. So we have two classes, and we want to connect them. One in your computer at your home, the other in my computer here locally in the office. Java. Does Java help me to connect them? And if yes, how? The answer, yes. How? With a library. And a library is a collection of classes. In particular, two classes that you need, socket and server socket. Are you telling me that this diagram when you transform this to a class diagram, that is going to be something like one class, the one that we are going to call the server, another class, the one that we're going to call the client. There is no connection between those two classes because those two classes exist in two different systems. You have this class in your computer and probably I have this class in my computer. Cannot be aggregation, composition, association, or inheritance because they are not in the same place. What is going to happen is this one is going to be using a class socket. And this one is going to be using, and this is UML. Server socket and socket. This is the class diagram for the software that you are doing, and it's going to run in the computer that we call the client. This is the class diagram for the software that I am doing, and it's going to run in a computer that we call the server. Very common error, guys. Please be aware of this. In the client server architecture, we're talking about two pieces of software, two different software systems. And therefore, for the client server application, for the client server architecture, if I ask you for the class diagram, always, we're talking about two class diagrams. The class diagram of the client, the class diagram of the server. Is not one class diagram because these two things are not connected. Professor, but there are connections here. The client and the server are connected. These connections here, those lines, represent the connection of the network. Those lines represent your Wi-Fi or the cable that you are using to connect directly. Those connections are not connections between the elements that conform the software. The software, two different pieces of software. This class socket is the one that is going to help us with the connection, and I want to show you the source code. Good? Clear the difference between the architectural diagram and the class diagram. One architectural diagram, however, two class diagrams, two different systems. Good? Okay, source code. I am sharing with you the source code for a server and the source code for a client. To be honest, screenshots, the tutorial of Java that you can find online. If you're familiar with socket, good. This is going to be very, very clear. Familiar, you have read this before. If you are not familiar with socket, please, homework. Review sockets during the weekend because we're going to use this for our next assignment. The goal of the next assignment is put together client server, Blackboard, and model view controller. So if you're not familiar with thread, Runnable, please review that. If you're not familiar with socket, please review that. There is no homework during the weekend. Moreover, there is no lecture on Monday. You have a week. My homework for you, my request for you, please, Runnable, thread, socket, and server socket. I need you to be able to use that in a project. So if you're already familiar, great, no homework. But if you are not familiar, please review a tutorial, check in the book. If you have questions, contact the TA, contact me, but you need to be able to use those for our next assignment. Anyway, this one, just to finish, you can review the source code during the weekend, but my concern, if I ask you for the class diagram, what is the class diagram of this source code? Can you figure out the class diagram? One class, right? Socket. Another class. Oops. The other class. So looks like that is connection between my client, socket, data output stream, which is the connection between this and between this. Hopefully everyone agree. How do you know? There is no global variables and there is nothing about inheritance. So the only connection could be dependency or association. And well, so far what is happening here with this variable and this variable is that both are being used. So just because they exist and they are being used, association, the solid line with the arrows, and hopefully we agree about the direction of the arrow, right? From my client to socket, from my client to data output stream. Clear. Obviously, you need to review the specifics about the functionality, but for our purposes, the class diagram is more important. So any question, guys? Good. Okay, please review sockets, review threads. Remember, no lecture on Monday. See you in a week. Thank you.